Hi guys, let's go over some solutions for our review. So the first ones we're going to go over are this distribution practice. So I have a study of seatbelt use among children involved in car crashes. Found that children not wearing any restraints had a mean hospital stay of 7.37 days, standard deviation of 0.79 day. 40 such children are randomly selected. Find the probability that their mean stay is greater than 7 days. So notice the emphasis here on mean, right? The probability that the mean is greater than 7 days. Well, because I have the probability of a mean being greater than 7, I know that I'm going to be using the central limit theorem. And so remember that that's actually the normal distribution, okay? Because n is greater than 30, right? And my mu x bar is going to be 7.37. And then my sampling error is going to be that 0.79 divided by the square root of 40, okay? And so whatever you use here, right? If you use Excel, you'd be doing the norm.dist. If you happen to be using a TI 84 or 83, then you'll be using that normal CDF, right? And so regardless of what you use, you will get the next answer here. So 0.9985 if you're rounding, okay? Number 2, Kemco Company manufactures tires that last a mean distance of 35,600 miles, the standard deviation. So A, one tire randomly selected. So probability that X lasts more than 35,000 miles. And so again, if you're using a TI 80 something, you'd have normal CDF and then 35,000, 10 to the 99. And I realize that many of you do not use the TI, use Excel, which is totally fine. That's what I've taught for my online classes. But for my in-person that have a calculator, I'm going to give them this look as well. So 35,000 up to 10 to the 99, and then my mean is 35,600, and my standard deviation is 42.75. Or if you're using Excel, you'll be doing 1 minus norm.dist, and then 35,000, 35,600, 4275, and true. Either way, let's see what we get. Let's see. So we're gonna have, give me just a second here, 0.5558. All right, part B. So the manufacturer is going to guarantee tires in the bottom 3%. So we're told that these are normally distributed, and that bottom 3% means that the area down here is 0.03. We want that X value, right? And so to find that X value, we're going to use that inverse norm. And again, depending on what you use, if you're using the TI 83 or 84, you'd have inverse norm, 0.03, a mean of 35,600, and a standard deviation of 4275. Or if you are using Excel, or norm dot inverse 0.03
Not
35,600 4275. And so then you get, let's see, where to go here? 27559.6. 27559.6. So they're going to guarantee tires up to that many miles. Okay. All right. Now part C, we have this probability that the mean life of a set of tires is less than 35,000. Okay. And again, if you're using the TI, you might go from like -10 to the 99 up to 35,000. The mean is 35,600. And then that standard deviation, be careful because we're dividing, right? This is the sampling distribution. And you've got 100 cars. And so I'm going to divide by the square root. And here, this might seem like a cheap shot, but 400, right? Because we've got 100 cars, 4 tires each. So there we go. Or if you're using Excel, norm dist 35,000, 35,600, and then 4275 divided by the square root of 400. Okay, and so let's see what we get. All right, so here we get 0.0025. All right. Number 3, U.S. Bureau of Justice data, 16% of all arrests are women. In one state, 400 arrests are randomly selected, 38 are women. We want to find the probability that the number of women arrested is at most 38. So let's identify the distribution. Well, it looks like we've got a fixed number of trials, namely 400. It looks like we're counting success as being an arrest of a female, a woman. That X would be 38. We have a probability of 0.16. And there's only 2 outcomes, right? Either a female is arrested or the person being arrested is not female. And so we're looking for the probability that the number of arrests is at most, so less than or equal to 38. Okay? Again, that less than or equal to corresponds to the language of at most. Well, what distribution is this? Binomial. Okay? And so on the TI, you'll be using binom CDF. If you're using Excel, you'll be using binom.dist. Whatever you use, you should come out with the following solution. So we get 1.1 times 10 to the -4. In other words, 0.00011. So the question is, does it seem plausible that this state conforms to the 16% national arrest rate? Well, this suggests not so much, because by random chance, this is so low. All right, last one. National Park has an elk density of roughly 3 elk per square kilometer. When elk population are at least 4 per square kilometer, aspen trees become susceptible to damage that can often result in a tree's death. So what is the probability that aspens in any given square kilometer are threatened due to the presence of elk? And of course, the moral of the story is that we need to do what?
Yes, eat more elk.
Yummy. Love me some elk burgers. Sorry, that's not part of the problem, and I am digressing. But it is ironic, since this distribution is poisson, which means fish in French. So we went from, think of it as surf and turf, I guess. How do I know it's poisson? Well, this is how. 3 elk per square kilometer, right? I'm given some mean over some interval. At least 4 per square kilometer. So I am looking for the probability at least 4. So greater than or equal to 4. Now remember, when you do this, we're going to take advantage of the complement, right? Whether you're using Excel or whether you're using the TI calculator, the Poisson distribution gives you probabilities from 0 up to a certain point. But we want the probabilities from a certain point and above. So I'm going to take 1 minus the probability that x is less than or equal to 3. So again, this 1, you should see probabilities 0 through all of them. And we're getting rid of 0 through 3. So what's left is 4 and onward. And so whatever tool you use, right, whether it's Poisson CDF or Poisson Dist, whatever, on Excel or the TI, this is the answer you should get. You get 0.3528. Okay, so that is the probability that aspens in any given square kilometer are threatened. Okay, all right. So this should have been a nice recap of some of the distributions, and particularly the 3, you know, the continuous distribution, normal, and then our 2 discrete distributions that we talked about. All right, so this concludes that review. Keep studying, and hope you're all doing well.